Hello and welcome to class. Today we're going to continue our lessons about heat, but first a joke. Did you hear oxygen went on a date with potassium? It went okay. You get it? Because oxygen is the symbol for, O is the oxygen, is the symbol for oxygen, and K is the symbol for potassium. You're welcome. You're welcome that I'm bringing a smile to your face. Okay. Today, you guys are going to learn about thermal equilibrium so that you can explain how heat transfers and moves. I know I've got it when I can identify which direction heat moves. Okay, at the end of class, you should be able to explain why you should defrost food in water instead of leaving it on the counter. So these are the things that you will be doing in class today. You're going to review phase change graphs to make sure that you understand them. You're going to complete an activity and hand it in to Google Classroom. You're going to take notes on thermal equilibrium, short notes. You're going to complete an Edpuzzle that is assigned to you in Edpuzzle. And if you finish early, you can work on the Black History Scientist Month about Black scientists. Okay, so here is phase changes of water. So this is a short 2-minute video that you should watch. And it talks again, review of when you go from a solid to a liquid to a gas, you are increasing the thermal energy, and it goes from a gas to a liquid to a solid. Excuse me, you are decreasing the thermal energy. Okay, so here you're going to drag to label phase change graphs. So again, looking at what's going on at each plateau or flat line here. So if you're starting here, so you're starting below zero, what's going on at this plateau? What's going on here? What state of matter is it here? What phase change is happening here? And what state of matter is here? You will see this graph again on the quiz. So you need to make sure that you're understanding this. Use your notes this is almost completely directly from your notes, but a review to make sure that you're understanding this. Okay. Down here at the bottom is what you'll take the notes on, but just listen for a minute. Whenever two objects, any two objects, come in contact with each other, heat will transfer or flow from the object with the higher temperature to the object with the lower temperature. Think about that. It will always go from, the heat will always transfer from the object with the higher temperature to the object with the lower temperature. The heat will continue to flow until the temperature of the two objects has equalized or reached the same temperature. So that explains why if you leave a hot cup of coffee out on a counter, eventually it will be the same temperature as the room that it's sitting in. And that's also why your cold drink, if it's 90 degrees outside and you have ice cold water, it will become the same temperature as the surroundings, because that heat will continue to transfer until those two objects are the same temperature. So for example, suppose you place an ice cube in a glass of water. Because the water is warmer than the ice, okay, the water is warmer than the ice, heat flows from the water to the ice until they reach the same temperature. Heat does not flow from the ice to the water. Okay, so here's what I would write down. I would write down this bold here. Heat will transfer from the object with the higher temperature to the object with the lower temperature. So you can pause this at any moment and you can write that down as notes. This is called thermal equilibrium. I would write that down. And then you're going to do, in the next couple of slides, you have examples, and I would draw some of the examples. Okay, so here is your example. I've got the water, the temperature of the water The energy from the water is going from the water to the ice cube. So that's why I have that arrow, the arrows pointing towards the ice. So drag the circle to the correct answer. So which has more kinetic energy, the water or the ice? Which molecules are moving faster, the water or the ice? Where is the heat moving, to the water or to the ice? How will the temperature of water change? The water temperature will increase, the water temperature will decrease. Move the arrows to show where the heat will travel. I had an arrow because at first I just had one, but then I got fancy and added a bunch more. Okay, so draw where the arrow would go. Is the heat leaving the ice cream, or is the heat going towards the ice cream? Move the arrow to show where the heat will travel. In this instance, we've got a cup of hot coffee sitting on a countertop. Again, pause at any time if you want. Here you've got ice cube in your hand. Which direction is the heat traveling? Is the heat traveling from the ice cube to the hand, or from the hand to the ice cube? Last one. Is the heat from the fire being transferred to your hands, or is the heat from your hands transferring to the fire? Complete the Edpuzzle that is assigned to you in Edpuzzle. So this is linked, so you can click on the link here. And it should take you to this right here. If notice there's only 3 questions. If you, for whatever reason, can't find it or it's not working, it's been assigned to you in a classroom, so you can go to any classroom. That was the temperature scales. So here is the one that is due for this class. Okay, so why is it that you would want to defrost your food in water? Is because now that we know the way that matter is composed, the water molecules in a liquid are closer together than the air. So there's more molecules that are, the heat is going from the water to the frozen food, in this case steak. So because there's more water molecules here and able to move more freely, and they're going to be closer together than they would be on the air sitting on a countertop, it will defrost it more quickly. Once you've completed and handed in your activities for today, you may work on the Black Scientist activity in Google Classroom. You have a quiz next class. There will be a review before the quiz. Are all of your notes up to date? If not, make sure that they are all up to date. And that is all that we have for today. Thank you and have a great day.